All right, so in this tutorial, I am going to show you how to draw in 3D in a new software called Inventor. You can work in 3D in AutoCAD. I have deliberately chosen not to use AutoCAD because I find the 3D functions really difficult to use. However, if you choose to go further drafting into post-secondary courses, you may end up using AutoCAD for 3D. For example, the Quantlin KPU partnership program, they use AutoCAD for 3D. There's also other software out there like Solid Edge, Fusion, like a number of other softwares out there that you can use to draw in 3D, but we'll be using one today called Inventor, and it's for free educationally as part of the Autodesk product line. That's part of why we use it. It's also an industry standard software, which means that if you choose to one day get a job as a draftsperson, you might actually use this software, again, because it's industry standard. So to get started with this, I want you to take a second to acknowledge that the junior drafting booklet assignment I have was made for Inventor 2009. As you can tell, the Inventor version we're using is much newer than that. So some of these instructions aren't going to make a lot of sense, which is why we're making the video to accompany this, because I'm going to show you where to find some of these things. For example, the 2D sketch panel, part features toolbar, all of those things don't exist anymore. So this, if you were to just follow these step-by-step instructions, you would not make it very far because the software is like completely different, which also lends itself to learning some of these shortcut keys, again, so that when there are new versions of software, you can find things a little bit more quickly than having to learn the software all over again. So to get started, this says launch AutoCAD or Autodesk Inventor, and then we're going to open a standard.ipt file. We need to add that it needs to be a metric standard IPT file because we're going to be working in millimeters. In the past, Inventor would default to metric. Now I don't know what it defaults to, so we can't just go to standard. So what we'll go is we'll go new. And when you click new, it's going to give you some options. So the first thing on the left side, there's English, metric, and mold design. Okay, English is inches, metric is millimeters, and then mold design is its own thing. So we're first going to select metric, and then the type of file we want is a standard IPT. That's up in the top section under part files. There's a standard millimeter IPT. This is the type of file that we're going to open. Just very briefly, there are different file types here. Standard millimeter IPT is where you draw a part. The next section are assemblies. This is where you take parts that you've drawn and you can put them together. And then there's a drawing file, which we'll get into shortly, but that's how you would do your orthographic projection, would be like this is the equivalent of paper space, whereas IPT is like model space. And then lastly, there's a presentation file, and that's where you can take something that you have assembled and you can explode it. And you can show how all the parts went together. So 4 very distinctly different file types, and that all serve different purposes. We'll be using standard millimeter IPT. The other thing that you'll notice when you open Inventor is that your background is going to be a little bit different and your zooming is reversed. So I'm going to show you first how to change that because it can be really disorienting when you go to zoom in and then it zooms out and then you get lost and you don't know where your assignment is anymore. So the first things first, your project will not open up like this with the blue screen. It opens with this like really dark gray screen, which is really hard on your eyes. So I would first go to File and then Options. And then you here under Colors tab, you can change the colors. I have it set to sky because I find that to be really easy on the eyes, and it has like a nice contrast for when you're drawing your lines. You can like essentially choose whatever you want. I believe that your computer defaults to one of these gray ones, maybe like Winter Night or something, or maybe Wonderland, I'm not sure. I just know that your background's dark gray and you draw in yellow, and I find it really hard on the eyes. So I'm going to pick sky, and then the other one you'll want is under display. Under zoom behavior, you're going to want to make sure that you select reverse direction because Inventor defaults to zooming backwards. So you zoom in, it zooms out. And again, that can be really disorienting. So these are the first 2 things I would probably do, and then apply, close, and then your background should change and that your zoom behavior should change. Now that that's done, we'll actually get started with the assignment. What are we drawing? We're eventually going to make this thing. It'll look like this when you're all done. It kind of looks like a camera, I guess, with like a chamfered front edge. And then these instructions go through how to draw that. So we're first going to start by drawing a rectangle. And this says click the 2-point rectangle tool, and then you're going to draw a rectangle that's approximately 75 by 45. So again, we can't just click the 2-point rectangle tool. First thing, we have to get into an actual sketch. So to start sketching, you would go into here, top left, where it says Start 2D Sketch, and you would click. And then it's going to ask you what plane you want to draw on. So you have your display cube here with like top, front, right. You can rotate it. And then here you can pick your XY plane or your YZ plane or whatever. I'm going to start by drawing on what would be considered the front. So that's the XY plane, or you can click the front of the cube and then click that plane. So I'm doing this so that I'm drawing on what would be like the front of the object. And again, I find this less disorienting to draw so that your preview cube matches up with your assignment. Again, if you don't do this step and you draw on a different plane, not a big deal. You'll just rotate your project later. So not a big deal if you miss this step. So we're going to draw a rectangle that's 75 by 45. So we do that by going into rectangle. We select. We can select where we want to start our rectangle, and then we can pull up, and then it starts to preview some measurements. So here we've got 16 by 10. Well, that's a little small. We wanted it 75 by 45. So maybe I'll zoom out a bit. Let's go 50 something by 20 something. No, 60 by 40. That's close. I'll click there. Now this is one of the main things that's different between AutoCAD and Inventor. AutoCAD, you type your dimension first, and that draws the object. In Inventor, you draw and then you dimension after. It's a little bit different of a process. So I've drawn this approximately the size that I want it, and now I'm going to dimension this object. I'm going to select this top one. It's coming up as 68, and this is where the magic happens. This is where I literally just type in 75 and hit enter, and then the whole shape grows to 75. I'm going to do the same to the side. It's 47. I want it to be 45. I type in 45, enter. Now it shrinks to 45. Now, when you actually draw in the rectangle command, you also have the ability to type the numbers in here. But again, this changes with every version of the software. So I would recommend that you draw approximately the size that you want, and then you dimension it to the size. So dimensioning in this case is different. It's different than we've used it in the past. In the past, when we use the dimension tool, it's to tell us the size of something we've already drawn. Here, we're using it to actually define the size of the object. So like a big change here. So now we have a rectangle that's 75 by 45. We've dimensioned it in two places. In the bottom right corner, we have an indication here that our object is fully constrained. That means that you can't make any more changes to this object because you've already set the size. There's no other things that you can dimension on this object. We're ready to create a 3D shape from this 2D shape. So to do so, here, this goes through dimensioning, and then it tells you to go into the extrude tool in the part features toolbar. It's a little bit different here. So what we would do is we would finish sketching in 2D. We would have our 2D sketch, and then we would go into creating a 3D shape. So right next to our 2D sketch, there's this create toolbar, and then we want to go into the extrude function. So the extrude function, if you've ever used like, I don't know, SketchUp or something, it's the same thing as like follow me. It's where you're taking your shape and you're pulling it from 2 dimensions into the 3rd dimension. So we're going to pull it up by a value that we've predetermined here as 8 millimeters. So I'm going to type in 8 millimeters, and you can choose which direction. So you can push, or you can go up, or you can split the difference and go up and down. It's really up to you. I'm just going to have it go forward and then OK. And now it's extruded. So you've essentially made your first 3D thing ever. Congratulations. That's it. And that's that whole first assignment. So we're moving from there on to creating the rest of the part, which is where we take our rectangle. Now would be a good time to save. So I'm going to go here, save as. I'll save it in what? Courses, drafting, examples and demos. And we'll call this parametric part 1. Now would be a good time to save. So I've saved that. I'm going to go in now to drawing the rest of the shape. So the next thing it wants me to do is it wants me to draw a circle on the front of the shape. So I'm going to click sketch. I'm going to click on the face that I want to draw, which is the front face of the object again, or you could click the cube and then select front. It's really up to you. And then I have to draw a circle on here. So it wants me to draw a circle that has a diameter of approximately 35. So I'm going to draw a circle. Some of these snap functions come up as well. Like if you hover over the side and you hover over here, you're able to track down and approximately find the middle. I want to first put in my circle at 35. I'm just typing in 35, enter. And then the next thing I'm going to do is I'm going to dimension this object so that the circle is centered. Oops. So I want to go from here to the circle. And then this dimension I want to be 22.5 as indicated in the assignment, 22.5, enter. And then I'm taking here and going from here to the side. And I want that one to be 37.5, enter. Now this, again, this is fully constrained here. So the circle, we have our diameter set, we have our center set. This thing isn't going to move. It's not going to go anywhere. And now we're going to extrude this into 3 dimensions. So to do that, you have to get out of the 2D sketch. You have to finish your sketch. And then you can go on your create toolbar and you can pull it into 3D. The next thing I want to point out before we do that is on our left toolbar here. It shows all the processes that you've done so far. So here you have extrusion 1. And if you drop it down, you have sketch 1. That was that first rectangle that we drew. Now we're into sketch 2. And then when we extrude it, it'll be extrusion 2. So if you want to go back and you want to change something, so like let's say that you realize you made a mistake and it's not supposed to be 75 by 45, it's supposed to be 65, you can literally click this and change it to 65. And then it shrinks. And then if we click finish, it will actually shrink the whole object by 10 millimeters. So this is a really nice function. If you get further on in your assignment and your parameters change, or your boss comes down and says, actually, your whole thing needs to be a little bit smaller, you can go in and make those changes and not have to redraw the whole thing. For the purposes of this, we have to go back and change it back. We actually do want this to be 75. And then it will grow it back to the size that we want it to be. So now we'll go into the extrusion tool. We're going to extrude this circle a distance of 22. So we'll go into the create toolbar, extrude, click. And then we want it to go a distance of 22, forward, because we want it to be up so you can see what's happening. OK. And then we have this shape. Ta-da. We can move on to the next part, which is making a hole. So if you're familiar with, say, woodwork or metalwork, if you need to drill a hole, first you need to mark where the center is going to be. So you mark where the center is, and then you take it to the machine and you drill the hole. Because you line up a drill bit with the center. It's the same thing when you use this software. You set the center and then you make the hole. So to do that, we're going to sketch, and we're going to sketch on this face, and we're going to put 2 center marks like we would again before going to drill something. Our center marks here, it's telling us that our center marks need to be, oh, sorry, we're doing this. My bad. Sorry. Escape. Finish. We're not doing those holes first. I jumped ahead. We're drawing here on the front face. We're going to put a point right in the middle, right here in the middle, click, and then finish our sketch. Now there's like a dot right on top, and we're going to put a hole through the part. So then to do that, again, in your create toolbar, or sorry, is it your create toolbar? Let's see. No, it's your modify toolbar. There's a function called hole, and you would click that. You'll click where you want the hole to be. So I've selected my center, and now you have to tell the computer like what type of hole you want to do, what the diameter is. So here it says 25 millimeters, and you want it to go through the whole item. So we want to do a hole, and we want the diameter to be 25 millimeters. And then as far as the depth, we want it to go through everything. So again, this window looks different than the window there because we're looking at a different version of the software. So here we can tell the hole to terminate. We can go here, counterbore, we can go spot, we can countersink, we can go through all, we can go through to a certain surface, we can type in a specific depth, we could say like just 10 millimeters. But in this case, we want to go through everything. So we're going to select termination through all. OK. Oh, I didn't want counterbore. I just want a through hole. No counterbore. Hole. OK, there we go. Oh, wrong size. How did I override that? Sorry, let's change that back. 25. There we go. So the hole now goes through the whole thing, through all. This is interesting because that whole toolbar is just new with this newest version of the software. So I haven't even seen that whole toolbar. So new for me as well. But essentially the same thing. The next part, we're going to do 2 center marks on either side, and we're going to put 2 small holes. So again, we go into our sketch toolbar, we click on the face that we want to draw, and then we put center marks where we want the holes to go. That's under the create toolbar. It's like a little point, center point. And then we'll click. They're going to be approximately here and here, and then we'll dimension them. We want to dimension them 27.5 from the center. So 27.5, and we'll go this one from the center, 27.5. And then we want to make sure that they're how far from the top? What was the overall height of this object? 35, I think. I can't remember. 22.5. There, so we want to make sure this is 22.5 down. So we'll go from here to here, 22.5, and then from here to here, 22.5. So now again, this is fully constrained, nothing can move. We've got our X and Y dimensions on our center points. They're not moving anywhere. We can finish the sketch, and then we can make holes. So we do that again by going into the modify toolbar, hole, and then you can click the centers where you want the hole to go. It's going to default to the last size you used. This hole is way too big. We don't want to make them this big this time. This time we're going to make them a diameter of 8.1. So we'll change that to 8.1, but it's still going to be through all. So you want the hole to go all the way through all, and then okay. And we have 2 holes going all the way through. And then the last thing, we have 2 more things to do. We're going to do a fillet and a chamfer. You're familiar with fillet. You've already done that in AutoCAD. It's very similar. So in the modify toolbar, we select fillet. We set our radius. In this case, we want our radius to be 10. Now the difference here is rather than clicking these 2 lines on the corner, so rather than clicking this one and then clicking this one and then having it round, we actually just click the edge. So we just click the edge that we want to round. If you were to click those 2 faces, I can show you what will happen. But if you click this face and then click this face, it actually rounds the whole face, which is not actually what we want to happen. So we'll go back into fillet. Modify, fillet, and we just click the corner. And again, zoom in, just click the corner, zoom in, just click the corner, and then the last one down here, come on, just click the corner. So we have all the corners selected, apply, and then close, and then we have fillets. Again, if you need to make a change, so say you typed in the wrong fillet diameter, you just double click fillet, you go in and change the fillet radius or whatever, and then it can go forward and change that. The last thing we're going to do is make a chamfer. You haven't made a chamfer before. This will be the first assignment doing this. So again, in modify, chamfer, this one we want to pick distance and angle. So there's distance, angle, and there's 2 distances. So we want distance angle, and we want it to be 5 by 30. And then to do this, I believe you click your face. It's on face first. So we click the face, and then we click the inside edge, and then it should taper in. And we apply and close. And then if we look at this, it should like taper inside. If you've done it backwards and you've tapered outside, what you did is you click the face and you click the outside edge. So all you have to do is go back into your chamfer and just fix it and click the face and the inside edge, and then it tapers in instead of tapering out. And then essentially your part is all done. And this is all that you have to do. You would save it at this point. You're all done drawing, and then you would move into actually putting it onto a layout. I'm going to do that demo a different day. So you can see how to do that part. I'm going to show you really quickly today, just so your mind's blown a little bit, just more or less how you would get started doing that. So I'm going to open a new file. I'm still in metric. And then this time I'm going to go down to the drawing section because we're creating a presentation file. And then I would open an ANSI millimeter, I think IDW is fine, or we can do an ANSI millimeter DWG. whichever one is okay, create. So the first thing I want you to notice is that it automatically sets the page size and it automatically puts in a title block. So that already saves you a couple steps. You don't have to draw the title block. You don't have to draw the border. So yay. The only problem is this is a really big piece of paper. So the first thing we're going to do is we're going to edit the sheet and we're going to change the size from a D size sheet to an A size sheet. An A is 8.5 by 11, what we're normally used to working with. And then again, I'm going to do this demo later and record it properly, showing you how to do this. But what sets this software aside from AutoCAD is this, which is where it generates the orthographic views for you once you've created an assignment. So I literally just clicked 4 times and it created the front view, the top view, the right side view, and then your 3/4 isometric. Like, bam, done. And you're probably a little bit angry right now that I've made you use AutoCAD all this time, but please don't be angry. This is a different software and it's a different learning. So in this case, you spend the time drawing the 3D object, it will thank you by generating the 2D drawings for you. And then you could go ahead and after that, you know, like put all your dimensions in and your center marks and your center lines and fill in your title block and all of that. But this is kind of the appeal to this software is not only can you draw in 3D, not only can you take that part file, send it, I could send it to the 3D printer right now and print it, but it also generates the drawings for you, which is like pretty sweet. So I hope that you have some buy-in in the software and you find it interesting, just like I do. My expectation of you when you're done your current assignment, your disaster relief shelter, is that you're going to move on to creating a parametric part and you're going to draw this part. That's my expectation. Then you can show me when you're done the part. And then I'll do the demo on how to actually do the layout. Your assignment, you're going to be handing in the drawing with the layout. You're not just going to be handing in the drawing. I mean, it's up to you. Do you want to have an assignment where you just hand in a screenshot of this? Or do you want to have an assignment where we go all the way through the end and do the layout? What would you like? So I'm going to ask that one more time. Do you want an assignment where you just do like a screenshot of the finished object and you hand that in for like a few marks? Or do you want the assignment to be all the way until you've put it on the layout and done your dimensions? Like either way, you have to do this step. My question is, do you want another assignment in between to get you a few extra marks? Sure? Is that extra marks? Okay, I'm fine with that. So as soon as this demo is done, I'll end the recording and then I'll post this as an assignment where all you're going to do when you're done drawing this object is just take maybe a screenshot of the finished object and hand that in, and you'll get a few marks for doing that. Questions, comments, concerns about using Inventor, how to get started, what to do, please make sure that you go back to this video and you don't follow the paper step by step. The paper is based off of an older version of the software. Okay? All right, happy drafting. All done.